Thanks for joining today, everybody. My name is Nate Drude. I'm an R&D and technical sales engineer here at Variscite. And with me is Fabio Tranchitella with Mender. He's head of product management. Today we'll both be presenting the webinar, How Familiar Are You with the Cybersecurity Regulations Affecting Your Embedded Device Design? This is our agenda for today. I'll give a brief introduction to Variscite, and then Fabio will give an introduction to Mender. After this, Fabio will present on regulations and standards like the EU Cyber Resilience Act, the US National Cybersecurity Strategy, and the ISA IEC 62443 standards for cybersecurity of industrial automation and control systems. Fabio will then also talk about ensuring security by design with secure device lifecycle management. And then we'll finish at the end with a questions session. Like I mentioned, we'll have a session for questions at the end of the webinar. You can write your questions in the question box as shown in the picture here. The questions may get answered in real time by our staff. Otherwise, Fabio and I will answer as many questions as we can live at the end of the webinar. Okay, an introduction to Variscite. Variscite is a leading system on module provider. We've been in the market for over 20 years and have built an extensive global customer base and pipeline. Variscite provides a stable supply by using our internal production facilities, giving us complete control over the manufacturing process. Variscite's hardware and software R&D team provides direct support to customers within 24 hours. We have the highest quality standards, meeting strict regulatory requirements, including medical standards. And Variscite has an ecosystem of partners like Mender that in the end allow us to provide a complete end-to-end solution to our customers. So why should you use a system on module from Variscite? Variscite SOMs offer scalability. We have several SOM families supporting many SoCs that allow for seamless scalability for current or future products and technology. SOM customization, Variscite offers complete customization of the SOM, allowing you to select the memory sizes and components on the SOM, allowing you to pay only for what you need. With Variscite, you can expect 100% yield all the time. You'll receive fully functional modules from Variscite. No need to manage the complexities of manufacturing and testing yourself. Variscite's hardware and software is production ready. We have BSP and driver support for multiple operating systems such as Yocto, Boot2Qt, Debian, and Android. The hardware and software is tested by Variscite and used by Variscite's large community of customers. Variscite provides free technical support for both hardware and software, allowing direct access to our R&D engineers using our customer support portal. And also all of our software is open source on GitHub. We provide access to the CAD files, and we have helpful guides and documentation on our software wiki. And last but not least, we have up to 15 years of longevity, so you can rest assured that you'll have long-term support from Variscite. So what is a system on module? In simple words, a system on module, or SOM, is the brains of the system. System on modules contain the most challenging parts of the hardware design and layout, like the processor, SoC, the memory, and the power supplies. And then depending on the SOM and the vendor, there will be some other common components like eMMC, Ethernet PHYs, Wi-Fi chips, audio codecs, etc. on the SOM. The SOM will have a board-to-board connector, which will connect the carrier board to the SOM, allowing access to as much of the processor's I/O and peripherals as possible. And then the customer is responsible for designing a custom carrier board for their application. This is shown on the picture on the bottom. Since the memory and the processor and the power are all on the SOM, the carrier board is both much more simple to design and can use less layers, allowing it to be both lower in cost and faster to develop. On the top, you can see there's an optional heatsink. For some SoCs or processors, the heatsink is required, and for others, it's optional depending on your environment and application requirements. Variscite has two scalable SOM families. One is named the Var SOM, and the second is named the Dart. On the left, you can see the VAR-SOM modules, which offer scalability from NXP's IMX6UL, IMX6, IMX8, 8M, and IMX93. And also, we recently launched the VAR-SOM AM62, which is based on the TI AM625 SoC. In general, each of these SOMs are pin-to-pin compatible with each other. And then the Dart family on the right has a smaller form factor, but actually provides more interfaces than the SOM family. It's also pin-to-pin scalable within its own family and supports scaling from the NXP IMX8M Mini to the IMX8M Plus. These two SOM families provide scalability and processing capabilities while maintaining the same interfaces and form factor, allowing you to scale from the Cortex-A7 and the Cortex-A9 processors all the way up to the A53 and A72, depending on your product requirements. So that was a brief introduction to Variscite. Now let's briefly talk about the partnership between Variscite and Mender. Mender provides a complete over-the-air update infrastructure that works with Variscite SOMs. This allows you to manage your entire device fleet and can enable a faster go-to-market. Their solution provides secured and signed end-to-end updates. It also provides device management and remote access. So for example, you can securely remotely access your device to do something like inspect log files or change a configuration file. And Mender can also help you meet cybersecurity regulation requirements. Variscite has a long-standing partnership with Mender. It started with integrations for the IMX6 and 6UL platforms. The collaboration was then enhanced with support of Variscite's IMX8 solutions, like the VAR-SOM MX8M Mini and Nano SOMs. In the end, integrating Mender enables Variscite's customers an out-of-the-box, secure, over-the-air software update solution. So that was a brief introduction to Variscite. I'll now hand the presentation over to Fabio to introduce Mender and go through the remaining sections.
Thank you very much, Nate. So my name is Fabio Tranchitella, and I am the CTO and product manager of Mender at Norton Tech. Can you go to the next slide, please? Mender is our flagship product, and it offers a complete end-to-end remote software management solution. It includes over-the-air firmware and operating system updates, as well as application updates. It works running an agent, which you run on your device, the so-called Mender client, and this software is responsible for performing updates, both in standalone mode and managed mode. In managed mode, it's connecting to a remote management server, either locally on the same network or remotely over the internet to the cloud. Mender is designed to be secure and robust, so firmware and operating system updates are using the A-B partitioning layout. This involves two partitions, A and B. One is active and one is inactive. When upgrading from one version of the operating system or firmware to the next one, the client flashes the new version into the inactive partition and reboots the device. We have a deep integration with the bootloader, so Mender will automatically switch the configuration, and during reboot, it will detect if something goes wrong. For example, the kernel panics and crashes, or the device doesn't have network connectivity. In this case, it will reboot the device into the previously active partition and abort the update. And this is the process we call rollback. So you can safely update your devices, reducing or removing the risk of breaking them. The server provides device management capabilities, including advanced features as troubleshooting or device configuration and monitoring. In particular, among the troubleshooting features, it's worth mentioning the remote terminal, which gives you the possibility to connect to the shell of your device. You can open a shell without running SSH or VPNs or similar technologies. At the same time, it gives you the possibility to transfer files to and from your device, start port forwarding sessions, and all these operations performed by users are logged into the system as part of audit logs and session logs. Mender is an open source project. It's licensed under the terms of Apache 2, both for the client and the backend. Additionally, we provide an enterprise version of the management server, which includes additional advanced features, for example, role-based access control, dynamic grouping, phase rollouts, which are also known as stage deployments, when you split your fleet of devices into groups and then you update them at different stages. Automatic retries in case of errors, synchronized updates, and so on. Next slide, please. Now that you know about our product, let me spend a few words about myself. As I mentioned before, I'm CTO and product manager of Mender. It means that I'm responsible for defining the Mender's technical architecture and the product roadmap. I have a background as a software engineer. I studied at the Polytechnic of Turin, and I have a broad experience in edge computing and IoT, specifically in secure device management. This includes embedded hardware selection, establishing the chain of trust from the hardware at the manufacturing facility to the cloud-based backend services using several different technologies, ranging from secure boot to storage encryption, software integrity verification, IP protection. I contributed to several projects for our customers involving PKIs, certificates, secrets, and credentials management. And in Northern Tech, the company behind Mender, I designed the backend and cloud infrastructure for our product. I also have significant experience in the free software movement. I've been an official Debian developer and package maintainer since 2004. Can we go to the next slide, please? So Nate, the previous slides presented the system on module offer from Variscite. It is important to mention that Mender is fully integrated and plays nicely with these modules. We just published our latest reference integration with a MX8 Mini module on Mender Hub. I don't know if you are aware of Mender Hub. It's our community forum where Mender users, both open source and customers, can ask and answer questions, share information, for example, in this case, integrations with new boards, and discuss Mender-related or, generally speaking, OTA-related topics. Using the link that you find on this slide, you will go to the page on Mender Hub, where we publish the reference integration using Yocto Kirkstone, and it includes AB operating system updates. If you have one of these boards, you can easily build your own distribution using Yocto and giving it a try without the need of running the Mender server on your own. Can you go to the next slide, Nate? So we have a special offer on Hosted Mender, our software as a service platform. You can sign up for free and you can get full access to all the enterprise features for up to 12 months, and you can connect up to 10 devices. So in this case, you can focus on the hardware integration and then try Mender end-to-end from the client to the server. If you have any issues, you can rely on Mender Hub, both for community users and Northern Tech staff that will answer your questions there. At this point, I believe we can go to the main topics of the webinar. So Nate, can you go to the next slide? We will cover a high-level overview of the cybersecurity regulations and standards, both in the US and in the EU. In particular, we will cover the EU Cyber Resilience Act, so the CRA, the US National Cybersecurity Strategy, and the ISA IEC 62443 standards. One important forward, considering that the edge computing market is still at its early stage and the legislative bodies are relatively slow at reacting to changes in the space, it will take time before these regulations will be published and enforced. We will see that some of them are proposals, some of them are high-level strategy documents. There are industry or use case specific regulations that can apply to your products. For example, I could mention the recent policy which the US Food and Drugs Administration published. It's really recent. I think it was published at the end of March, so literally 3 weeks ago, about cybersecurity in internet-connected medical devices. This is an interesting example because it's very narrow, both in targeting, it only focuses on internet-connected medical devices, and in scope, because it mainly focuses on software vulnerabilities, assessment, monitoring, and the process for updating the software which is running on these devices. So what we can expect in the near future is a fragmentation implementation of the cybersecurity regulations into industry-specific and use case-specific policies. But then the question will be how to design your embedded systems to be secure in a landscape where these regulations are still under definition. Today, the best answer I can provide to this question is trying to understand the basics, the guiding principles that are behind these general purpose regulations and proposals, because the concepts which the industry-specific standards and regulations will expand on are the ones covered by these general purposes, proposals and strategy documents. And this is what we will do in the next few slides. So let's start with the regulations in the European Union, and in particular with the EU Cyber Resilience Act. Can you go to the next slide, Nate? Thank you very much. So first of all, the Cyber Resilience Act is not a regulation in the European Union. It's just a proposal, which the European Commission published in mid-September 2022, 6 months ago. The main reason for this proposal is that as different economic sectors have become more and more dependent on digital technologies in executing their businesses, the opportunities that digital connectivity brings at the same time expose economies to cyber threats. So given the complexity, scale, impact of cybersecurity events, when everything is connected, a cybersecurity incident can affect the entire system, and this can have a huge impact, both economic and social. So for this reason, the Cyber Resilience Act is aims at introducing a set of rules to protect digital products that are not covered by any previous regulation. So according to the European Commission, this will be the first Internet of Things legislation in the EU. And somehow you can make a parallel between this Cyber Resilience Act and the infamous GDPR, which I suppose you all know about data protection and privacy, because the GDPR changed the way companies handle data about their customers in the EU. So stretching the concept, the Cyber Resilience Act is going to be the equivalent of the GDPR, just for a different topic, the security of the Internet of Things. The first draft includes a set of essential requirements for the different actors involved with edge devices: hardware manufacturers, software developers, distributors, and importers of digital products and services in the EU. The main requirements are setting up an appropriate level of cybersecurity for your products. You cannot sell or distribute products with known vulnerabilities at the time of distribution. You have to provide a security by default in configurations, protecting access in order to avoid unauthorized access to the devices, limiting as much as possible the attack surfaces, and minimizing the impact of incidents. The Cyber Resilience Act splits the products and the services into 3 main categories. The biggest one is the so-called default category, which consists of low-risk products, and this covers 90% of the market. So smart toys, TVs, fridge, generally speaking, any consumer electronics. The main requirement for products and services belonging to this category is performing a self-assessment, a periodic self-assessment, in order to ensure that the product meets the cybersecurity requirements. The rest of the products and services fall into 2 categories: critical class 1 and critical class 2. The first category includes browsers, password managers, antiviruses, so all network connected devices, but also devices and chips that fall under the NIS2 directive, so the Network and Information Security Directive number 2. It includes also all operating systems, microprocessors, and industrial IoT devices, which are not covered by class 2. The second category, so class 2, includes higher risks products, so desktop and mobile devices, virtualized operating systems, general purpose microprocessors, card readers, robotic sensors, smart meters, routers, firewalls for industrial use cases. The main difference between the 2 categories, so critical 1 and 2, is about the compliance process. In the critical class 1, companies are required to apply a standard or a third-party assessment. In the class 2, the assessment must be performed by a third party. But independently from the category your product belongs to, the European Commission asks manufacturers to perform regular tests in order to identify vulnerabilities in their products. So the main message is that the product cannot be shipped to end users with known vulnerabilities. It means that if you distribute a product in the EU, you must continuously scan the software which is running on the device and will run on the device in order to identify vulnerabilities and have a process to update it and fix it when appropriate. As we already experienced with the GDPR, the member states will have to put in place bodies and offices to perform audits and checks. And the penalties, if you don't comply with the requirements, are significant, can amount to up to 2.5% of the annual turnover, up to 15 million euro. This is just a proposal, and the EU member states will meet again in June, the Communication Council, June 2023, to discuss the progress on this file. Honestly, we don't know what's going to happen because the digital files were not ranked very high in the agenda under the Swedish presidency. So it's unlikely that this will happen. The agreement will be signed and it will become a directive by June. But in any case, once the Cybersecurity Resilience Act is going to be published, companies will have 2 years to comply with the regulation. And as the expected life of many products is significantly longer than 24 months, you should start incorporating the basic principles in your product's design and development from now. So what are the basic requirements that the CRA is dictating? Basically, security through the process of planning, designing, and developing your product. You have to perform a risk assessment, and the products should be shipped, delivered to users without any known vulnerability. As I mentioned before, the configuration should be secure by default, and you should provide a factory reset to reset the device. Access to the device should be protected, so no default users, no default passwords to access the device. All the data should be encrypted both at rest or in transit. So data confidentiality is a priority, and data integrity as well. So data should be checked as well as software running on the device with reports in case of corruption. You have to limit the attack surface on your device storing only relevant and necessary data on the device, and protect the device from denial of service, so resource exhaustion. And in case of network devices, you have to minimize the impact of these devices in the network they are connected to. When it comes to the software which you're running on the device, you have to identify all the components you're running on the software and their vulnerabilities. So in this context, the so-called SBOM, so software bill of materials, will play a crucial role. You have to list all the software running on the device, from the operating system to the application that you're running, and all the libraries you depend on, and periodically check if there are known vulnerabilities. In case of vulnerabilities, you have to provide a process in order to remediate it. Disclosure is important, so letting the customers know that there is an update and it's fixing one or more vulnerabilities. And all the process of updating the device should be implemented according to a policy. At the same time, you have to provide a contact point for your users in order to communicate with you in case of security issues. All these processes are part of an operating standard that you have to implement for your product, with a continuous testing of your product and its security in order to address vulnerabilities. There are also additional requirements about technical documentation that you have to ship with your product, which should include the risk assessment, description of standards and compliance you follow, reports of tests on vulnerability handling, and in some cases, the software bill of materials. Can we go to the next slide, please? So at this point, let's have a look at what is happening in the US. While not exactly the same concept, we can consider the national cybersecurity strategy as the equivalent of the European cybersecurity legislation proposal. The first national cybersecurity strategy was published back in 2002. It's a document which gets updated every few years. The Biden administration released its first update on the 2nd of March 2023, so a bit less than a couple of months ago. But what's the purpose of this document? As the national security strategy does for national defense, the national cybersecurity strategy outlines the top priorities regarding cybersecurity issues. It's very important to highlight that this document is not a directive. It's rather, it describes in general terms what the administration is most concerned about, who are the major adversaries and threats, and how the administration can achieve its goals through actions. So these types of documents are often aspirational, outlining a vision more than a concrete action. Just to give you an idea, the strategy is based on 5 pillars. So defend critical infrastructure, disrupt and dismantle threat actors, shape market forces to drive security and resilience. So as you see, these are very high level concepts, but we have to decline them into concrete and actionable items when we are building products and services. So if we analyze the content of the latest version of the document, 2023, we can find a few interesting points, which I want to highlight in this webinar. First of all, it calls for improved sharing of information between the government and the private sector about cybersecurity threats, vulnerabilities, and risks. This requires producers, manufacturers, and companies operating devices to collect this information about their products and services. For example, as mentioned before, you have to know which software is running on your device. So you need a software bill of materials. You have to continuously scan the software for vulnerabilities, and you have to perform both static and dynamic threat monitoring. This is a new concept which was introduced this year. So keeping track of all the vulnerabilities on your device and sharing this information is going to be a requirement. At the same time, the document states that no product is totally secure. We know that. But the administration will work with the Congress and the private sector to prevent companies from being shielded from liability claims over the security of their products. This is because the products that we ship to end users underpin the society, and the strategy observes that mitigating these risks is too much of a burden to end users. And this aligns very well with the requirements that we discussed in the previous slide about the European Cyber Resilience Act. So the effort of keeping devices secure is moving from end users to the producers. The device should be secure by design, and it should be possible to update it so we can fix new vulnerabilities that will appear as the time passes. The strategy document scope is broad, and it covers additional topics that are not relevant in this case. So, for example, it expands on federal cybersecurity workforce and the importance of protecting the country's critical infrastructure and the federal computer system. This is not relevant for us. But despite the visionary statement and the high-level concepts that are contained in the document, the US National Cybersecurity Strategy is interesting for us because it defines the foundational layers for industry-specific regulations, which are usually narrower in scope and more actionable, like the one that we discussed a few slides before about medical devices which are connected to the internet. Next slide, please. So at this point, we have a general overview of the strategies about cybersecurity, both in the European Union and the United States. So we can have a look at a set of standards that are commonly used in OT, operational technologies, across multiple industries. So the ISA IEC 62443 are a set of standards. So there are different standards that apply to different industries that define requirements and processes for implementing and maintaining secure industrial automation and control systems. These standards are best practices about security and provide a way to assess the level of security performance of both processes and products. Their approach to the cybersecurity is holistic, so it bridges the gap between operations and information technologies, and as well as between process safety and cybersecurity. These standards set cybersecurity benchmarks in different industrial sectors and can be applied to industrial automation and control systems, including, for example, building automation, electric power generation, medical devices, transportation, process industries, chemical, oil, gas. In 2021, the International Electrotechnical Commission, so the IEC, approved this family of standards as horizontal standards. And this is extremely important and relevant because it means that when sector-specific standards, like the one we discussed before about medical devices, will get defined and developed by subject-specific experts, the IEC 62443 standards must be used as foundational, as a layer, as a starting point. This approach was decided in order to avoid the proliferation of partial and conflict requirements for addressing cybersecurity of operational technologies across different industrial sectors, where at the same time similar technology and products are deployed at operating sites. So using these standards, we can apply the same foundational layer across different industrial and automation sectors. When applying these standards, you target specific maturity and security level. This can be confusing because maturity and security level are disconnected from each other. So the maturity level describes a scale of the maturity of the process you are following in order to address a specific security level. So just to give you an idea, the maturity level 1, the supplier carry out product development which is undocumented or ad hoc, while level 4 is the level when the product supplier can have appropriate metrics, is collecting metrics about the process and improving it in a feedback loop. What is really relevant for us is not the maturity level, but the security level. So there are different standards and different requirements between systems and products. The standard which applies to products is the 62443-42, and it defines different security levels for products. And these different levels have a different set of requirements. So we start from level 0, so no special requirement or protection required. And as we increase the security level number, more larger set of requirements needs to be enforced in order to get the certification. So level 1, we need to protect the device or the product against unintentional or accidental misuse. Level 2, we need to protect it from attacks with simple means, few resources, general skill, low motivation. And we go up to level 4 when we need to protect the product from very sophisticated attacks. Each of these levels brings a set of requirements that needs to be implemented. So at this point, we have a general understanding of the regulations and standards about cybersecurity for edge devices and Internet of Things. But let's try to zoom out and see it in a more actionable way. So let's put all this information in the context of a complete device lifecycle management. In the next slide, can you go to the next slide, please? Here we represent the different steps that are part of device lifecycle management. Every product goes through all these phases, and there are several aspects that you have to take into account in each of these steps in order to make your device lifecycle secure. In the first phase, we have the design, where based on the product requirements and the specific use case, you have to select the security level you want to implement. Here you can compare it with IEC standard we were discussing a couple of slides before, and device lifecycle management mechanisms and how you implement them. This is the phase where you select the hardware based on your specific requirements, the storage layout, for example, encryption, boot loader integration, including, for example, secure boot, in order to make sure that your device can only run software that you digitally sign. In the next phase, you have the manufacturing process. This is where you assemble the physical product. So you have the hardware and you provision the initial software which we run. This is when you perform QA and you ensure that the product is ready for sale. As I mentioned, this is when you inject or you provision the initial software, and this includes the generation of unique credentials and unique identifiers for this specific device. The result is a birth certificate, which usually includes crypto materials, so certificates or public key, if you're using private public keys pairs, and you can use this information to authorize this device to talk with a backend service which is running in the cloud, for example, if you have to get or push data, pull or push data to the cloud. When you turn on the product in the field, you enter the commissioning step. The product starts generating value for the customer, and this is only possible because the product registers itself with a backend service and starts sending and receiving data. Often this step involves a first boot update, because there is a lag, there is a period of time which is passing from the manufacturing process and the commissioning step. And in the meanwhile, you could have vulnerabilities that you discovered in the software that you need to fix with a first boot update. So you can ensure that the latest version of the software is running on the device. This is also the stage when the device gets configured with unique settings, which are customer specific because it becomes operational. At this point, we enter the maintenance phase. So the device is operational. We want to monitor the device to ensure that it works as expected. We have to continuously scan for vulnerabilities the software that is running and make sure that we can update the software to fix them. At this stage, automation is crucial. So that's where you implement CI/CD pipelines, OTA, software update platforms, usually with device management capabilities, and you have to manage credentials, for example, secret rotation. So this is the phase where you have to automate as much as you can, because you want to reduce the latency. If you want to fix something on the device, or if you want to perform a secret rotation, you want an automatic system that can make it for you. Once the device life is over, or the hardware fails, or there is end of support, end of contract with the customer, the product needs to be decommissioned. This is an important phase because all the credentials that you have on the device must be revoked. The device should be deregistered from cloud services. So you want to prevent the device from communicating with the cloud services. And all the secrets, all the data, all the IP stored on the device should be cleared. Because the device can eventually be recommissioned in a different location, for example, getting back to the commissioning step for a new cycle. So in this case, you want to reset the device and make it ready for the next step. Security must be taken care of all across the device lifecycle, and this is possible only through a proper design and the implementation of a secure device lifecycle management. What to do, how to do it in each step depends on different factors, on the specific use case, on different requirements, but these are more or less the high-level steps and the high-level processes that you have to take care of when designing the device lifecycle management. And we can go to the next slide. And at this point, we can open the floor for questions.
All right, thanks, Fabio. I'm going to switch the view here so I can see the questions. As a reminder to everybody, you can go to the questions panel and type in your questions, and Fabio and I will do our best to answer these questions in real time here. I see the first question we can ask for you, Fabio, is can you share an example of how OTA has been integrated with a secure element on an edge gateway to create a secure chain of trust?
Thanks, Nate. So as we mentioned before, during the manufacturing phase, we need to establish a chain of trust between the hardware that we are manufacturing and the cloud services the device will communicate with. There are many ways you can establish this trust. The most common way is injecting credentials. So usually it's X509 certificates, so TLS SSL certificates, or using private public key pairs that you inject into the device. But if the device supports a hardware security module, secure element, for example, a TPM2 compatible component that you can access from the Linux kernel, you can leverage it to identify the device and establish this trust. So using a secure element on the edge gateway, you can store crypto materials in the hardware and use this crypto material to perform verification, to sign credentials, and, for example, to verify signatures on software updates. There are many implementations of hardware security in the embedded systems. Just to give you an example, with the Mender client, so our agent which is running on the device, if you have a TPM2 compatible hardware security module, you can use it to identify with the server and get authorized from the server, performing mutual TLS authentication. So in this case, you can leverage public key infrastructure and make sure that those credentials can only work with that specific gateway because you rely on the identity of the security element, which is part of the board.
Great, thanks. Thanks, Fabio. Another question for you. Can you provide us with an example of the implementation of the IEC 6244342 standard?
Yes, first of all, this standard, the 4.2, is about products. So it's the standard which focuses on products. And just as an example, in Norton Tech, we supported one of our customers, which is distributing heating systems, to certify their edge gateway according to the IEC 6244342 standard. The system involves a Linux gateway, which uses hardware security, so a hardware security module discussed, to authenticate with the backend using a pre-existing PKI. Thanks to this, we achieved zero-touch provisioning. So the device connects to the cloud and gets authorized because of the trust which is established thanks to the certificates that we are storing in the hardware security module. So there is no manual operation. The device gets authorized automatically, zero-touch provisioning. As the device identity and authorization keys are stored in the hardware, there is no way a hypothetical attacker could impersonate the device and get access to the backend. This is one of the main issues you have with the devices. You are storing credentials on the device, which an attacker could use to connect to the backend. But if they only work on the device because they rely on the hardware, this is not possible. Zero-touch provisioning and hardware security modules are not enough to get certified. So there are other, for example, in this case, other Mender features that played a crucial role in the certification process. So role-based access control, audit logs, but also the possibility to sign and verify software updates to ensure that only authorized software can run on the device were requirements for the given security level that the customer aimed at when performing the certification.
Okay, thanks. Another question for you. What are the types of attacks against which we should guard our devices?
Well, this is a hard to answer this question is hard to answer because there is no general answer. So generally speaking, the attack surface for edge devices must be reduced to the minimum. The devices should reduce to the bare minimum the number of network ports and interfaces exposed on the local network, because most of the threats are coming from network connections or interfaces. And just to give an example, this is why we designed our remote terminal feature to work without any open port on the device. It's leveraging the same connection we use for OTA purposes, which is protected by TLS, so encryption in transit, but we don't open any network port. So I would say that the major type of attacks is coming from the network and from the interfaces. However, as a general rule, you also have to reduce the amount of data your device is storing locally, in order to avoid data leaks. And you have to pay attention to the default configuration. So this is one of the requirements from the European Cybersecurity Resilience Act. The device should be secure by default after a reset. So no default username, no default passwords, and should not expose any service which is optional, should be opt-in. Access to the device should be provided only to authorized users, and the device itself should be monitored and audited. When it comes to the software, you should track all the software that is running on the device in the form of software bill of materials and check for known vulnerabilities, both for applications and operating system or firmware. You have to establish a process and a set of procedures to update, usually over the air, the software when applicable, and inform customers about the vulnerabilities. Additional threats or possible attacks can be the denial of service, abuse of resources. This can be a threat, but this should be addressed in your applications in order to avoid abuse. And of course, there are additional attacks that can apply to specific devices, environments, or different use cases, but this needs to be evaluated case by case. So it depends on the scenario where the device is operational.
Great, that's a good answer, thanks. You mentioned software bill of material. The next question is about software bill of materials. It comes up regarding multiple standards. Is there, I think the question is around, what does a software bill of material look like? Is there some example? Is it a high-level list of software or a very detailed list? What type of software bill of material is generally necessary? Is there an example of that?
As of today, there are no strict requirements in terms of format. So it's not about producing a specific SBOM or software bill of materials according to a predefined format, but the requirement is to track each version of the software and libraries that you are running on your device in order to be able to share this information with the end user. In some cases, it's not required for all the devices and all use cases, and use this information to keep track of the vulnerabilities that will become known over time. So it's not about the format itself, it's more about collecting this information. When it comes to producing the software bill of materials, it really depends on your build system. So there are several recipes, for example, in Yocto, that can create the software bill of materials for you at build time. If you're using binary distributions, so not Yocto based, but Debian or Ubuntu, this is an information you can always get from your package manager. So it depends on how you build your software. But again, the focus is not on the format itself of the software bill of materials, but more on the data which is in it and how you can use this information to update your devices when a new vulnerability is discovered in your software stack.
This makes sense. Thanks for explaining that. Another question for you. During the maintenance phase, it's necessary to continuously scan the software for vulnerabilities. Do you have any suggestions on tools or partners, or what's the best way to continuously scan for vulnerabilities during the maintenance phase?
There are many tools, both open source and commercial, that can perform continuous scanning of the software. Generally speaking, the requirement is scanning the software based on the versions that you have in the software bill of materials. There is no need to perform scanning on the devices themselves. This is because the edge devices are usually constrained in terms of resources, so you don't have to run a process on the device itself to perform any scanning. We have customers, we know about users that are performing dynamic threat monitoring on the devices, but this is not part of any regulation, any requirement, any standard. So when it comes to performing these scans, this can be a scheduled job, running one of the many tools that are available in the open source community. I'm thinking about containers. We have many customers running containers on their edge devices, and the standard tools you use for vulnerability scanning for containers can apply to edge devices as well. So you know the versions of the containers of the images you're running on your device, and you can continually scan them and get to know if there is a known vulnerability.
Okay, thanks. Regarding the EU proposal, there's different categories of devices. Who and how are new device? Who categorizes new embedded devices? How do you know which category the device will fall into?
The proposal, which again is just a proposal, we don't know exactly how it will evolve, contains some rules. So looking at the proposal, you can categorize your product into the default category, which is 90%, or one of the critical categories. Generally speaking, there are specific products that fall into the critical categories because they are more, as the term says, more critical in the infrastructure. So operating systems or network appliances, firewalls, gateways. So these are devices or solutions, software solutions that fall into the critical category by definition. Most of the consumer products or electronics products are going to fall into the default category, but the rules, the exact rules, are still under definition. I don't think there will be a centralized body defining where your product falls into, but it will be your decision based on the set of rules, and you will have national bodies in each of the EU member states that will perform checks. So it's similar. I always use the GDPR as a benchmark. It's similar to the way you have to categorize the data you have in PII data or non-PII data. It's based on you. You make the decision, and then you have an external body that can check you. So there is no centralized body, according to the current proposal, that will make this categorization for you.
Okay, thank you. Probably have time for one or two more questions. One question regarding credentials that are stored on the device. What are some of the best practices and protections for storing and protecting credentials on the device in the field?
It's very hard to answer the question. I can probably provide just a few hints, a few pointers, but it depends on the specific use case. So first of all, no shared credentials on your set of devices, because that's the worst thing which can happen. So every device will need to have unique credentials specifically for the device. And in the best scenario, you're relying on hardware security. So you're storing them using a TPM compatible hardware security module. So in this case, the credentials are not stored in the storage layer of the device, so an attacker cannot get access to it, even with physical access to the device. One of the key aspects, in my personal opinion, is rotation of these secrets. So making sure that you can rotate those credentials periodically in a fully automated way, which is similar to the concept of OTA. When you perform updates to the software, you can use device management capabilities to change, rotate certificates or connection strings you have on the device. General rule of thumb, never store credentials in clear text on the storage of the device. Make sure that you can rotate them at will when needed. And an important thing I want to highlight again, take care of decommissioning those credentials when the device gets decommissioned. So revoke them as soon as the device is not operational anymore.
Great, thanks, Fabio. We're coming up to the top of the hour here, so we're gonna wrap up the webinar now. We'll go to the next slide. If there was a question you asked that we weren't able to answer, here's some of the ways to contact us. Specifically, you can send the questions to either sales@variscite.com email, or if you're signed up for the Variscite customer portal, you can log in there and ask your questions as well. We can help route you to either the correct person at Variscite or Mender to help with the questions. You can go to variscite.com for our website. You can also go to veriwiki.com for our wiki, which has all the documentation and guides for getting started on Variscite SOMs. And all of the Variscite software is open source and available at github.com/verigit. So on behalf of Variscite, Mender, and Fabio, thank you for joining us for our webinar today. We hope to see you next time.
Thank you very much, Chase.